These are notes from section 7.7, which is on L'Hopital's rule. It's got a little hat on the O here. It says if the limit as x approaches c of a quotient, f of x divided by g of x, is in indeterminate form, so you're trying to evaluate the limit, you plug in c, and you get indeterminate form. There's lots of different indeterminate forms. The only two that you need to be concerned about for this class is 0 over 0 or infinity over infinity. So we substitute c in. If we get 0 over 0 or infinity over infinity, then you can use L'Hopital's rule. If you don't get one of these, then you can't use this. Then the limit as x approaches c of f of x over g of x is equal to the limit as x approaches c of f prime of x over g prime of x. Basically, we can take the derivative of the top and the derivative of the bottom and then try again. Notice this is not the derivative of this thing. You would use the quotient rule to find the derivative of this. I'm just taking the derivative of the top, the derivative of the bottom, and dividing them. All right, so let's try one. It says number 5. Let's go number 1. Limit as x approaches 2 of x squared minus 4x plus 4 over x cubed minus 12x plus 16. Step 1, direct substitution. Just plug in 2. 2 squared is 4 minus 4 times 2 plus 4. I've got 0 on the top. If I plug 2 into the bottom, I get 8 minus 24 plus 16. I get 0 over 0. 0 over 0 is indeterminate form, so I can use L'Hopital's rule. The way L'Hopital's rule works is if I want to evaluate this limit, I can just take the derivative of the top, the derivative of the bottom, and divide them. Now plug in 2. 4 minus 4, I get 0 on the top. 4 times 3, 12 minus 12, I get 0 on the bottom. We are still in indeterminate form. We can use L'Hopital's rule again. Derivative of the top is 2. Derivative of the bottom is 6x. Now plug in 2. I get 2 over 12, which is 1/6, which is the answer. So as long as you are in indeterminate form, you can continue to take the derivative of the top and the derivative of the bottom. Number 2, as for the limit as x approaches pi over 2 of 1 minus sine x over 1 plus cosine 2x. First thing you always need to do is direct substitution. If I plug in pi over 2, I get 1 minus sine of pi over 2 is 1. That's 0. Here I have 2 times pi over 2. That's pi. Cosine of pi is negative 1 plus 1. I do have 0 over 0. We can use L'Hopital's rule. Derivative of the top would be negative cosine x. Derivative of the bottom is negative sine 2x times the derivative of 2x, which is 2. Plugging in pi over 2 gives me 0. Sine of pi is 0. We're still in indeterminate form. We can do it again. Derivative of negative cosine x is positive sine x. Derivative of sine of 2x would be cosine of 2x times 2, and I already have a 2, so this is going to be a 4. Sine of pi over 2 is 1. Pi over 2 times 2 is pi. Cosine of pi is negative 1 times negative 4 is 4. 1/4. Number 3, substitute the 1 in, gives me 0 on the top. 4 minus 1 minus 3, 0 on the bottom. We can use the L'Hopital's rule. 3x squared over 12x squared minus 1. Derivative of the top, derivative of the bottom. Try again. Here I get 3 over 11, which is not indeterminate form. That is my answer. Start by substituting. Plug in 3 gives me -1 divided by +1. That's -1. That's it. That's the answer. L'Hopital's rule, again, only works if it is 0 over 0 or infinity over infinity. One like this, if you had taken the derivative of the top and the bottom, you get 1 over 1, which is +1, not -1. Let's go number 5. Let's evaluate the limit as x approaches infinity of 2x squared plus 5x minus 1 over 4x squared minus 2. The fastest, easiest way to do this one is to remember the rules for horizontal asymptotes. The limit as x approaches infinity. The degrees on the top and the bottom are both 2. So you would divide the leading coefficients, 2 divided by 4, and get 1/2. 1/2 should be the answer. But suppose you don't remember that. You can use the L'Hopital's rule to evaluate this as well. Plugging in infinity, I've got infinity squared plus 5 times infinity minus, that's infinitely big. The bottom's infinitely big. So we've got infinity over infinity. We're going to use the L'Hopital's rule. To do that, we're going to take the derivative of the top, 4x plus 5, and the derivative of the bottom, 8x. Plugging in infinity still results in indeterminate form, infinitely big divided by infinitely big. So we're going to do it again. Derivative of the top is 4, derivative of the bottom is 8. Plugging in infinity just gives me 4 over 8, which is 1/2. Boom, same answer. A couple more here. These are a little bit more challenging. Number 6 says this is a graph of g prime of x right here. This graph is g prime of x. It also tells us g of 2 is -3. It wants to find the limit as x approaches 2 of this, g of x all squared minus 4x minus 1 all over 3x. Well, the first thing we would do is plug in 2. So that would be g of 2 squared, and g of 2 is equal to -3. So -3 squared is 9, minus 4 times 2 is 8, minus 1. I've got 0 on the top, plugging in 2, I've got 0 on the bottom. We are indeed in indeterminate form. So we need to use L'Hopital's rule, take the derivative of the top, derivative of g of x squared, derivative of something squared, we put the 2 out front, subtract 1 from the exponent, times the derivative of the inside. Derivative of minus 4x is minus 4, and the derivative of -1 is 0. Derivative of the bottom is 3. Now plug in 2. So I've got 2 times g of 2. G of 2 is -3. Times g prime of 2. Well, this is a graph of g prime. So g prime of 2 is 2 minus 4 all over 3. We've got 4, -12 minus 4, -16 over 3. And the second one over here gives us a table of values. We're asked to evaluate the limit as x approaches 1 of f of g of x minus 3 all over x squared minus 1. So the bottom's 0. Let's see if the top is 0. So f of g of 1, g of 1 is -2. F of -2 is 3, 3 minus 3, where you have 0 over 0. So we can use L'Hopital's rule. Plug in 2 Derivative of the top, derivative of f of g of x would be f prime of g of x times the derivative of the inside. Derivative of x squared minus 1 is 2x. Plug in 1. So I've got g of 1. G of 1 is negative 2. G prime of 1 is negative 1. Bottom, I've got 2 times 1. F prime of negative 2 is 4. Negative 4 over 2, which is negative 2. So that is L'Hopital's rule. It's a fast, relatively easy way to evaluate limits that are in indeterminate form. Reach out if you have any questions.